Hello everyone, I am Siriji from Sri Venkateshwara College of Engineering, studying in 6th SEM, Department of Computer Science and Engineering. I am here to discuss about the topic Functions in Lex and Yacc, Lex and Yacc program to print Fibonacci series. Functions in Lex. Lex and Yacc are tools used for generating lexical analyzer and parsers respectively for programming language or other formal languages. Lex and Yacc are often used together to build the front end of a compiler or an interpreter. Lex is a lexical analyzer generator that takes a set of regular expression as input and generates a lexical analyzer in C or C++ code. The lexical analyzer, also known as lexer or scanner, reads the input program character by character and breaks it into meaningful tokens based on specified regular expression. Lex provides the following function. YYLex. This function is the main entry point of the generated lexer code. It reads input characters and returns the next token found. YYText. This variable holds the actual lexeme that was recognized by the lexer. It can be accessed within the action associated with regular expression. YYIn. This variable is the input file stream used by the lexer. It can be set to read from a file or from the standard input. YYOut. This variable is the output file stream used by the lexer. It can be set to write tokens or other information to a file or to standard output. Lex is a popular computer program that aids in generating lexical analyzers, also known as scanners or tokenizer. Lex is typically used alongside the Yacc tool to build complete compilers or interpreters for programming language. Here are the main functions of Lex. Tokenization. Lex assists in breaking down the input source code into meaningful units called tokens. Tokens are the smallest unit of a programming language, such as keywords, identifiers, operators, literals, and punctuation marks. Lex allows you to define regular expressions that describe the patterns of these tokens and generate corresponding token recognition code. Pattern matching. Lex utilizes regular expression to match patterns within input source code. You can define regular expression in Lex to specify the lexical structure of token. When the input code is processed, Lex matches the regular expression against the input, identifying the corresponding patterns and generating appropriate actions. Rule-based scanning. Lex operates based on a set of user-defined rules. These rules consist of regular expression and corresponding action code. Lex matches the input against these rules sequentially, and when a match is found, it executes the associated action. This allows you to perform specific task or operation based on the identified token or pattern. Action code generation. For each rule in Lex, you can specify an associated action code. This code is executed when the corresponding pattern is recognized. The action code generated by Lex can be written in the programming language of your choice, often C or C++. It allows you to define custom behavior for handling token such as storing values, performing calculation, or invoking specific function. Error handling. Lex provides mechanism for handling lexical errors in the input code. You can define rules to recognize invalid or unrecognized token and define appropriate error handling action. These actions can include reporting an error, discarding the erroneous token, or recovering from the error state. Integration with Yacc. Lex is commonly used in conjunction with Yacc to build complete compilers or interpreters. While Lex focuses on tokenization and pattern recognition, Yacc handles the parsing and syntax analysis of the input code. Lex generates the token stream that Yacc consumes, facilitating the overall process of compiling or interpreting a programming language. Overall, Lex simplifies the process of building lexical analyzers by providing a high-level interface to specify token patterns and associated action. It automates the generation code for scanning and tokenization, enabling developers to focus on the higher level aspects of building compilers or interpreters. Next, coming to functions in Yacc. Yacc is a parser generator that takes a context-free grammar as input and generates a parser in C or C++ code. Bison is a popular and widely used variant of Yacc. The parser analyzes the structure of the input program based on grammar rules and performs action associated with each rule. Yacc provides the following function. YYParse. This function is the main entry point of the generated parser code. It starts the parsing process and returns 0 if the input program is successfully parsed. YY error of message. This function is called when a syntax error is encountered during parsing. It can be customized to provide meaningful error message to the user. YYLVal. This variable holds the semantic value associated with a token. It is usually set within the lexer code and accessed within the parser action. YY line number. This variable keeps track of the line number of the input program being parsed. It is typically incremented by the lexer. YY wrap. This function is called at the end of the input to determine if parsing should continue or terminate. By default, it returns 1 to indicate the end of input. In addition to these functions, both Lex and Yacc provide various directives and options to customize the behavior of the generated code, such as defining token types, associativity and precedence of operators, handling of semantic values, and more. By combining Lex and Yacc, you can define a complete language specification, including the lexical structure and grammar rules, and generate a working compiler or interpreter for that language. Yacc, short for Yet Another Compiler, is a tool that is commonly used in the field of compiler design. It is typically used in conjunction with Lex, a lexical analyzer generator, to automate the process of generating parsers for programming language or other formal languages. Yacc helps in the construction of a parser, which is a component of a compiler responsible for analyzing the structure of the input source code. Here are the main function and features of Yacc. Grammar specification. Yacc allows you to specify the grammar rules of a language using a formal notation called Backus Norform (BNF) or extended Backus Norform (EBNF). These rules define the syntax and structure of the language being processed. Parser generation. Yacc takes the grammar specification as input and generates a parser in a programming language such as C, C++, or Java. This parser is responsible for recognizing the valid syntax of the input source code based on the specified grammar rules. Bottom-up parsing. Yacc uses a bottom-up parsing technique known as LALR, look ahead left to right, parsing. It constructs a parsing table based on the grammar rules and uses a stack to track the parsing process. Reduction actions. Yacc allows you to associate actions with grammar rules. These actions are typically snippets of code written in the target programming language. When a grammar rule is reduced during the parsing process, the associated action code is executed, allowing you to perform specific task or computation. Semantic analysis. Yacc parser can include semantic actions within the reduction actions. These actions can perform additional checks and computation based on the structure and content of parsed input. Semantic analysis helps in validating the correctness and meaning of the input source code. Error handling. Yacc provides facilities for error handling during the parsing process. It can generate error recovery routine to handle syntax errors and attempt to continue parsing the input. Error message can be customized and augmented with contextual information. Symbol table management. Yacc parser often incorporates symbol table management. Symbol tables are data structures that store information about variables, function, and other symbols encountered during the parsing process. Symbol tables are typically used for scope management and type checking. Integration with Lex. Yacc is commonly used in combination with Lex or other lexical analyzers to form a complete compiler toolchain. Lex generates a lexical analyzer that breaks the input source code into tokens, and Yacc processes these tokens to construct a parse tree or perform other parsing tasks. Overall, Yacc simplifies the process of building parsers for programming language or other formal languages by automatically generating the parsing code from a high-level grammar specification. It helps streamline the development of compilers, interpreters, and other language processing tools. Next, coming to Lex and Yacc program to print Fibonacci series. Lex and Yacc are tools commonly used for creating compilers and interpreters. Lex is a lexical analyzer generator, while Yacc, yet another compiler, is a parser generator. They work together to process and analyze source code written in a specific language. To print the Fibonacci series of a given number using Lex and Yacc, you can follow these steps. Define the Lex file, usually with a .l extension. In the Lex file, we define the regular expression patterns and the corresponding actions. Here we define a pattern for matching numbers 0 to 9 plus and return the matched number as a token called number. We also define a pattern for matching any other character and return it as a single character token. Next, define the Yacc file usually with a .y extension. In the Yacc file, we define the grammar rules for the input. Here we have a single rule input that expects a number token. When a number is parsed, we calculate and print the Fibonacci series up to that number. We initialize A and B as the first two Fibonacci numbers 0 and 1, and then we loop until B exceeds the given number n. Inside the loop, we swap A and B values and calculate the next Fibonacci number. B plus is equal to A. We print each Fibonacci number using printf. Finally, we call printf/n to print a new line. Compile the Lex and Yacc file using these commands: lex lexer.l, yaccdparser.y, gcc lex.yy.c, y.tab.c, o Fibonacci. Run the program and provide a number as input. The program will prompt for a number, and after you enter it, it will print the Fibonacci series up to that number. Input is 6 and the Fibonacci series is as follows: 0, 1, 1, 2, 3, 5, 8. And this is all about Lex and Yacc program to print Fibonacci series. Thank you.